Hello, everybody. Thanks for not going outside and having ice cream today. Um, when starting a new application, consistency seems really easy. New screens are developed and designed closely together, often by just a single designer and developer. Any small inconsistencies can be ironed out really quickly, but just going through the app together and ironing out those issues. But fast forward a few years, and the situation often looks quite different. New people joined, others have left, and the designs as well as the features evolved a lot. And suddenly, your application is full of 10 different buttons that just look slightly different and out of place, and a lot of different designs throughout the screens because they were built at different times. My name is Maria Neumayer, and I'm an Android developer at Deliveroo. Deliveroo is a food delivery service, and we have 3 applications to build: a consumer, a restaurant, and a rider app. All those 3 apps were built by completely different teams. So even though there were some similarities, like colors, for example, a lot of the components and screens were very different. But we wanted to get from this to a unified design. So how do you get from this mess to a consistent look and feel? And how do you ensure it actually stays consistent going forward? Now, we decided to tackle this issue by using a design system. So what's a design system? A design system is a set of visual styles, UI components, and guidelines that are used to build applications. And these components can come with rules and constraints. So, for example, a button can only have 3 different types: a primary, a secondary, and a tertiary type. And a specific text style can only be used for headings, for example. And all of these rules and guidelines can help with consistency, because they give people something to work with. It can also help with scaling. Both designers and developers can benefit from being able to use existing components. Creating a new component takes a lot of time. There's a lot of back and forth between designer and developer to make sure that really works exactly how you want it to. But if you make it reusable, you can use it lots of times going forward, and you only have to go through this process once. It can also help prevent duplication. How often did you create a new style and then created a pull request, and somebody says, hey, this already exists somewhere else in the app? Or maybe even worse, nobody notices, and suddenly you have 2 different styles for the same thing, and they'll slowly get out of sync. So with a design system, you have a single source of truth. So you don't have to go through the whole application and check every single screen to make sure that this component or style doesn't exist somewhere else. One design system you might be familiar with is material design. Before the introduction of material design, Android was known for its inconsistency. Every application looked completely different. And even within the operating system, screens would just look very different depending on where they were. There were also not many components that you could use. And so every application ended up building their own version of this navigation drawer. And they all behaved slightly different and causing a lot of confusion to the user. With the introduction of material designs, a lot of guidelines to follow and components to use came. And for that, consistency slowly started to happen across the operating system, with applications actually following those guidelines. So chances are you're already using a design system. But what if you want to create your own? Where do you actually start? And when and how do you actually create components? And how do you then distribute them for everybody? Before setting up a design system, make sure you have both designers and engineers on board. If only engineers go and create components, there's still going to be a new custom version on every different screen, and you can't actually reuse them properly. If only designers are using them, if the design changes or the component changes, then you still have to go through the application and update all your screens because you don't have a component on the development side. So you have to work together on this with your designers to make sure that you create a design system together. At Deliveroo, the push originally came from the designers. They had to build 4 versions of every screen in the application. So they had to build an iOS version, an Android version, a mobile web version, and a desktop version. So that takes a lot of time. And there were not really many rules around this. So while there were some shared components, there were still a lot of custom components all over the place because there were no guidelines around when to use a component and when to create a custom version. So it made a lot of sense to simplify this process, and so a design system team was created. Now this design system team set up a unified set of standards and components that were used across all platforms to build the apps, while still following platform conventions where it actually matters, like navigation or input, so the application still feels home within its environment. We all hate getting iOS designs from our designers on Android, so this doesn't happen. This design system lives in Figma, which is a tool for designers to create designs. The good thing about Figma is that both developers and designers can access it and see exactly what they need. So we can access the properties that this component has and then develop them on our side. We can also see the changes in real time. So as a designer is currently working on a component, we can give feedback and help out in case a component is actually not that easy to build within our app. On the Android side, we mainly wanted to avoid duplicating components across our three applications. We realized at some point that we actually had quite a few things in common that we wanted to build, but because we had separate repositories, we weren't sharing them that much. We did already have a shared repository for some of our common code, so we decided to create a module in there, which we called UIKit. Now, this name actually turned out to be bad, because on iOS, a UIKit already exists natively, so we can't use the same name on iOS. So we should have really checked with our other team members to ensure that it's the same name on iOS as well as on the web, where they essentially called it a component library. But we essentially created this before we really had a design system, because we just wanted to share components across the apps. But because this module lived in a separate repository, the lines between what the application was and what the module was, or what the UIKit was, were really separate. Even if you just have one application, I really recommend keeping it at least within a separate module. So there's a clear separation, and the lines aren't too blurry, because you can easily just add a new color, and then this somehow becomes part of your design system, even though it isn't actually, and it's just an exception to the rules. All right, so with this being actually really separate, we also had some challenges to integrate this UIKit within our apps. We started off by using Git submodules. Now, with Git submodules, you essentially point your application repository to another commit in a separate repository. And this essentially becomes part of your app. So if you work locally, the folder is checked out, and you can just modify the code and do whatever you want. But that also comes with its issues, because the line is quite blurry. You might accidentally change code in the UIKit, even though you actually wanted to change your application. But until you actually try and commit those changes, you're probably not going to notice. So this is very different from any other dependency that you use. And it's also not very straightforward to use. For somebody who isn't used to Git submodule, it's very difficult to figure out how to actually push something to the UIKit and then get those changes back into the application. And even if you don't actually make any changes, somebody else makes a change, and you then pull the latest version of your repository. And suddenly you have this change, but you didn't make any changes to the submodule. But turns out you just had to update it. So it isn't very straightforward to figure out how to use Git submodules. It also slowed down our builds a bit, because even though these common libraries didn't change often, you still had to rebuild them whenever there's a clean build, because they were part of your application. So we decided to ditch Git submodules and use a private Maven repository using Artifactory instead. Now, there's a bit of a setup to this, but once you've done that, it's really straightforward to use this. So on the application side, you just integrate it like any other dependency. The only thing that you have to watch out is that you also add the actual private Maven repository and its credentials to your list of repositories, because you need to tell it how to actually log in and how to get these the data from there. And then to publish changes, there's a Gradle task, and it's just called Artifactory publish. And then on our side, that is actually done on CI. So all you actually have to do to get publish a new version is do the changes, increase the version, and push a tag. And CI will actually automatically build that. And on the app side, you just update the version. So just like any other dependency. If you want to know more about how to set up your own private Maven repository using Artifactory, Jeroen Mols wrote a really good blog post about this a few years ago. So check it out. So this made it a lot more straightforward to use and also helped with the build times because the UI kit wasn't part of our application. But it came with a bit of an overhead. First, we had to think about versioning. Most dependencies use semantic versioning. So you split up your version into a major, minor, and a patch version. The major version is for breaking changes. So if you update the dependency and you have to modify your code, you're going to have to update the version. It's a major version. Minor changes are generally for new features. So for a UI kit, it would be a new component. And the patch version is for little tweaks and bug fixes. So generally, if you update, you don't have to really worry about those. So we wanted to use the same because it made it easier to figure out how hard an update would be. We also kept a set of release notes. If you update the version, you want to know what actually changed. So is there any new components I can use that I can replace? Or is there anything else? Maybe a component was updated and has a new feature now. So it's very useful to see the release notes. Now, if you just have one application, you're probably not going to have to worry about these things too much. But I really recommend keeping a set of release notes because it's useful to figure out what actually changed and what you have to do. Okay, it also helped us to work closer together because we could work on these components together across the whole Android team. Before, we were quite separate, but now we're working a lot more closer together because we're reviewing each other's code for these components that we create. And we make sure that every team actually reviews this code to make sure it works for everybody. But it made it a bit more difficult to actually test the changes. So if you create a component and you want to know that it actually works within your application, you have to actually publish a new version. But you don't really want to do that. But luckily, you can also publish locally. So all you have to do is publish to Maven local, and then on the application side, also include Maven local in your list of repositories. So that's useful if you want to just test a finished component that you've already created to make sure it actually works within your use case as well. But it's not a viable option during development. So we also created a thing we called a component browser. In there, we have a representation of each of our components in every single possible combination they come in. So if you create a component or if you modify an existing one, you can quickly test if everything is still working correctly or if one of the configurations actually doesn't work anymore and isn't rendering correctly. It also is good to figure out which components actually exist and what they support to know if you have to create a new one or if you can use one that already exists. Now, we wanted this to be possible to use this component browser as a standalone application, so you could build it relatively quickly, and also be able to integrate this within our own applications in a debug panel, for example. So we had to create a separate module just for the component browser, which could be integrated within our app as a library module, but also have a standalone application module, which is pretty much empty, and it's just there to start this component browser. All right, so that's the setup done. But how do you actually create components? One of the first components we created were colors and text styles. We had a set of brand colors that we used for many years, as well as text styles. But over time they changed, and new styles were added, and new colors were added, and others changed slightly. And so at some point, we just had a list of colors with many exceptions, and some of them matching the design system, and others not. So we wanted to have a fresh start when we actually started with the UI kit, and actually do it right. Now, first up, naming. We wanted to have a consistent language between designers and developers. Have you ever asked a designer for a color of something, and they come back with a name, and you check the app, and that name doesn't exist? So you ask for the hex code, and then they come back with a hex code, and you check you actually have that color, but under a different name. So you have to go through this whole back and forth just because you're using inconsistent naming. So we really wanted to avoid that. So each of our colors has a name, like teal in this example, as well as a number that indicates the shade, like 100. So both in the UI kit in Figma, which is the thing on the background, and within our application, which is in the bubbles, we use the same name. The same for text styles. Each text style comes with a type. Is it a body or is it a heading? As well as a size. So in this case, it's medium. And then optionally, you can have a strength. Is it bold? And a color. But default, they're all black. All right, so setting these up was quite easy, but integrating them in the app wasn't too much. Because we had all those inconsistent colors, we had to somehow map our old colors to the new ones. And we really wanted to be consistent with colors, because it's such an important thing of the application. Luckily, our designers created a full mapping of all our colors, how they were before, and how they should look now. So all we had to do is go through the whole application, update the colors one by one, and go through a few exceptions together, because they weren't covered in this mapping. But by going through this together, we could iron out those issues relatively quickly. With text styles, it was a bit different, because the old styles and the new styles were actually very similar. The biggest thing that changed was the naming, as well as a bit of the line spacing. So we decided to not go through the whole application and update all the text styles, but we made sure only to use the new styles going forward, and updating screens as we went along. Updating the whole component throughout the whole application is going to take you a lot of time. So weigh up the options with your designers to make sure you only go through this if you really have to, and consistency is really important. For us, it did mean going back through our text styles at some point when we replaced our main font with a different one, because we didn't want to have two fonts in the application. But because we've done all that work already, it wasn't that hard to go through the rest of them and update them. All right, so we have text styles and we have colors. Now these are very important for a lot of other components. So we could actually start on some more complex components. Now, one of the first one we created is a button. We had many buttons in our apps, and most of them didn't really match the design system. And a lot of them were very similar. Maybe they had elevation, and another didn't. There was no reason why those differences were there. It was just because our styles were a bit messy. But even in the design system, our button component was really complicated. It had different types, a primary, a secondary, and a tertiary button. And all of these could come with an enabled property, be inverted if they're in front of a dark background, have a destructive style if you want to delete something, have a loading icon, or be shown with or without an icon. So in total, you have 42 combinations. And we really wanted to make sure that this button component looks the same and matches the design system in all of those combinations. So in general, when you create a new component on Android, you have two different options. It can be either a style or a custom view. Now, our old buttons were just styles, because it's the easiest way to style an existing button and make it look as if it's part of your application and not just a default button. It's also very flexible. If you want to just change the background to some special background, you just override the background property. But that's also a downside, because suddenly you have 10 different styles of your button that all look slightly different. Maybe they have a different padding or a different text style, or the background is different. So you really have to watch out with styles to make sure you're not just creating styles everywhere. They can also be a bit restrictive. You can't actually update a style programmatically. So if you want to change from a primary to a secondary type, you have to update all of the background, all of the properties manually. So if you change your style, you're going to have to also update this code. So it can be a bit error-prone. The other alternative is that you have two views and switch back and forth between them. But that's also not really a great option. We also had issues replicating the button component with just a style. We wanted the icon to align next to the text, but if you use a compound drawable with a style, the icon will actually be aligned to the side of the view instead of next to the text if the button is full width. So we couldn't really use a style for this. So we ended up with a custom view instead. With a custom view, you have full control over your components, so you can do exactly what you want, exactly in the way you want it, and you can be as flexible or as restrictive as you want. We wanted to be a bit more restrictive, so it made it a bit harder to add some exceptions if you really needed them. Another issue was that it is hard to work with third-party libraries. For example, on the consumer app, we have a third-party library called Soapbeam that we use for our live chat feature. So customers can go online and chat to customer support if they have an issue with their order. But we wanted those buttons within that screen to actually be able to style, so they look as part of our application and not something else. So we couldn't replace their button with our custom view. And so we had to actually replicate our component as a style. So it's not great, but the downsides or the restrictions of a style were a bigger issue for us. So when you create a component, you have to choose what really works for you. Maybe you need more flexibility, or maybe you want to be more restrictive and have more consistency. And that can be different from case to case. In this case, we opted for more consistency. Okay, so we know it's a custom view. But we also wanted to be consistent with the naming, with the design system. But in there, it was called a button. So that would clash with the default Android button. And we wanted to make it clear that this isn't just the default Android button, so you're importing the wrong thing. So we added a prefix and called it a UIKit button. And this is a convention we kept using going forward. So any component is easily identifiable as part of the UIKit. And you know it isn't just another component in your application. Okay, so we have a name, and we know it's going to be a custom view. But how do you actually structure this component? We wanted them to be as easy as possible to use. So we wanted it to be configurable via both XML as well as in code. So we had to set up some custom attributes. Now, again, we wanted to be consistent with the naming. So exactly these properties exist in our design system for the button component. Okay, so these are quite a few properties. You have a text, an icon, a type. Is it inverted, or is it loading, or is it enabled? So these are quite a lot, and you don't want to set them every time. So we also came up with some sensible default. So if you want an enabled button, with a primary type, no inversion, no loading, no destructive state, and without an icon, you just need to set the text. So it's very easy to use. We also made it possible to actually set those properties differently by a theme, by setting up a style attribute. So if you have a dark screen that needs the inverted button type, you can set the inverted property to true for this theme. Now, programmatically, exactly the same. We have these properties, and you update them, and the component updates. So you can control exactly the same things that you can control in XML, also programmatically. Apart from these properties, we don't really allow any additional styling, and that's for two reasons. First, it forces consistency. It can be really, really tempting to have a really special look and feel for just one button. But if you're not careful, you're going to end up with many, many different special cases. And suddenly your button doesn't look more consistent, like we had the issue with styles before. So if you're restrictive, you need a really good reason to change it, because it either means creating a custom button or updating the design system. The other reason is it actually can simplify the component. You don't have to think about what happens if somebody changes the background and you then change the type, because you have to update the background. Should it stay or should it not? I don't know. So if you don't allow it, you don't have to think about these. That doesn't actually stop somebody from doing it programmatically, but it'll take a lot more effort to do it. Now, you might have run into issues like this with some material design components. Maybe you tried to have a multi-line text on the collapsing toolbar, or you tried to show a title, tab title for the bottom navigation view when there were more than 3 tabs, where the title would actually hide automatically. These things are surprisingly hard, and it turns out there's a reason for that. because they want to be consistent. They don't allow it on purpose. Now, there's probably a smaller likelihood that this happens if we control both the component as well as the application, but both designers and engineers need to really be aware of the limitations. And sometimes it does mean adding exceptions. We had this tab bar component, and like any tab bar, a tab can either be selected or unselected. But in the rider application, we needed an additional visual cue to indicate that there is a tab that could be selected, but you couldn't actually book anything behind this. Now, our designers really wanted this change, so we had to figure out what we had to do, or what we should do. We didn't want to add support to this within the component directly, because it wasn't actually part of the design system, so it shouldn't be there. But we also didn't want to not use this component, because it would meant copying all this code into the rider application, and then this tab bar component would probably get out of sync quite quickly. So we decided to allow a bit more customization on the component. So you can add this resting text color for a tab. So this can also be used for other use cases. Maybe in the future we want to highlight the tab specifically, so we can indicate that there's something behind it that you really want to click. All right, but when do you actually create a component? We don't have a dedicated team for this, so we only want to create components when we actually need them. So is it actually easier and faster if there is an existing component? Is consistency actually important? And are there actually multiple use cases for this? And if so, then yeah, create a new component. It will be useful for you. And it could be that you already have some kind of version of this component in your application, but it's not quite as flexible and doesn't support all the use cases it does as it would in the design system. For us, a common case was that a component existed in one application that was needed in another application. And so we could extract this component into the UI kit, so everybody could actually use it. And that could give us a base of this component. We could iron out a few of the API issues or bugs, and then use it in every application. And even if the component doesn't actually exist yet, it can still be useful to create it first for your specific use case, to figure out how you actually want to use this component, and see if it actually does what you want it to do. Our components became more and more complicated over time. What started off as just simple colors and text styles quickly became single components, and then compositions of multiple components, like this empty state. And that is actually quite a natural progression. And turns out there's a name for that, and that is atomic design. With atomic design, your components get split up into 5 distinct levels. You start off with atoms. These are the smallest blocks that you can't really divide any further. One example would be a button. Now you might think, hang on, a button has an icon, it has a text, it has a background, it has loads of other components. You can easily divide it, but a button can't exist without them, so it is still an atom. Next up are molecules. These are essentially multiple atoms combined. For example, a row item. This has an image, a title, and a subtitle, for example. Each of these components can be standalone, but together they form a molecule. And then you have organisms. These are more bigger and more complex components, like a dialogue, for example. Templates. These are essentially the XML layout of your activity. So they're the layouts without any content. And finally, pages. These are the final end result that the user actually sees. So they're the pages with the real content. So from stage to stage, it gets more complex until you actually end up with the final screen. In a design system, you're probably not going to go much further than organisms, because templates and pages are for specific use cases. If you want to know more about atomic design, there was a really good talk about this last year here by Yahya Bayramoglu, so check it out. Now, there's one component I still want to talk about, and that is icons. We had a full set of icons from design, but we had to figure out how to actually integrate them in the application. This was probably one of the most complex issues for us to figure out how to do, and how to actually get it really right. Our designers did a lot of the heavy work for us. So they generated all those icons automatically into SVG and then converted them into Android vectors. So we had the files ready. We just didn't know how to use them in the app. We started off by just copying the files across. And that was useful because we could have a separate tint and a separate size for each of these icons. So they were really flexible to use. So even if you wanted to use it as a compound drawable, where it was really hard to tint the icon until recently, you just set it in XML. So it was really straightforward. But it also came with its issues. We couldn't update those icons. Once they were in the application, they stayed there. And we'd had to either go and update all those icons manually, or they would probably more likely just get out of date, because it takes a lot of time to update all those icons. Also, copying those icons turned out to be quite frustrating and tedious. So we really wanted to find a solution on how we do this better. So we had the full list of icons exported, so we didn't have to worry about that. And what we ended up doing is create a small module around this list of generated icons. The icons essentially lived in a repository, which was our generic design system, which was used by everybody. And there, the application, which was just a JavaScript application to actually generate those icons, lived. So now, whenever the icon set gets updated, we publish a new version on Artifactory via CI, and then get a notification on Slack. So all you have to do is integrate it like any other dependency, and update the version whenever the icons change. So this made it a lot more straightforward to use all the icons that we have and get the latest version of it. It does mean we have to tint and resize those icons manually, but maybe in the future we'll have a set of icons with all the different tints that we actually need. So no more updating icons manually and copying them across. That's great. This is definitely something I wish we'd done earlier, because now it means we have to go back throughout all of those old icons and remove them and use the UIKit version instead. So we're at a pretty good foundation now, but there's still a lot more components to build and a lot more inconsistencies to iron out. But we've come a long way from about a year ago when nothing of this exists. So what's next? One thing that we're not really good is making sure that our components actually stay up to date. Our design team generally writes a message whenever the components change, but we might miss this message or forget about it. And then at some point, we either notice in Figma that this component doesn't match the designs don't match our component, or a designer notices in the application that it's out of date. So that's not great. So we have to work a lot closer together with the design system team to make sure that doesn't happen again. Our web engineers, they have a catch-up every 2 weeks with the design system team to give updates both on the design team as well as on the development side. So this could be something really useful to do. And it might also help us to actually create more components, because if 2 weeks later we don't have any updates, it's a bit embarrassing. So we want to have something to show. Another option is that the design system team creates GitHub issues in our repository. So whenever the component changes, we know exactly what we have to update. And even if we spot that later, we know what we have to do. And it's in our repository, so we will notice at some point. But those changes are still manually, and some things you want to change should automatically happen pretty much. Maybe colors and text styles. If that changes, do you really have to actually go and update the text code manually? Now, there's a thing called design tokens, which Salesforce uses heavily. And those are essentially the core styles of your application. So colors, text styles, maybe some dimensions. And these get generated into a JSON file. And then this essentially generates a platform-specific version. So whenever these styles update, this JSON gets generated, and then it generates the platform-specific version. So Android XML resources and styles for Android. On the development side, all we have to do is pull the latest changes, and we don't have to update any of these styles manually. So that's very similar to what we're doing for icons. So I'd love to be able to get to something like this for more things. Another thing we might want to do is modularize our UI kit, Currently, we mainly have our common components that we're using across all applications. But I'm sure we're going to get to some more specific ones that are either used by one app or maybe one feature even. So we don't want to increase the app size by just adding components and components that are not actually used everywhere. And we also want to avoid slowing down the builds in the UI kit, which is currently really, really fast. So modularization can help a lot with all of that. So all of that shows that even a year long, we're still very much at the beginning of our journey to a full design system. But it's been really useful to work with this for consistency as well as speed. It also brought us a lot closer together as a team, both within the Android team as well as with the design team, because we could work on these components together and build them like we want them. Creating new components is really hard. You have to consider a lot of use cases and make sure the language is actually consistent and the component is easy to use. But in the end, it's really worth it. So I hope this could help you to build actually your design system. Thank you.